Hi everyone, welcome to our video on cost function applications. So, cost functions are often linear functions, and linear functions are very common. So they are involved in such things as like paychecks, bills, cost, revenue, profit, so forth. But math books often like to focus on cost, so that's what we're going to focus on these here. But if they are these other types of scenarios, it is broken down in a very similar fashion. So let's take a look at our cost function form. So instead of like f of x, they use a capital C for cost. So this is the cost. And then it's equal to mx plus b. M is still the slope. However, often we don't need to graph it, so we might not need to use the slope. They might call it some other things, though. With our cost function, the m can be called marginal cost. So that's a vocabulary word for our slope for cost function. It's also often used whenever you see something per something. So if it says, I'm just going to put per, so the word per often means that that's going to be our slope. Okay, and then b would be, so kind of up above, I'm doing the original vocabulary. So the b gives you the y-intercept. But in cost functions, it might be called something different. It's often called a fixed cost. So that's a vocabulary phrase for it here. Okay, and then the cost is usually in dollars. So we've got C of x. Let's put this over here. C of x is usually in dollars. So that means the C of x, so the cost of something, whatever it is at the end, is in dollars. Whereas the x is usually the number of something. So it depends on the problem, but this is kind of a general case that we can break it down as. So let's break this problem down here. So it says Go-Karts charges a $30 entrance fee into their park and $5 per race that you enter. Write a linear cost function for Go-Karts and identify all variables used. Okay, so they do tell us it's linear cost. So we do know the form is C of x equals mx plus b. And then what we really need to do from here is just break down what these are. So we've got the $30 entrance fee and we have $5 per race. And you could do whichever one you're more comfortable with first. Remember with word problems to always read it very carefully and to break it down piece by piece. And the order often does not matter. So for instance, I'm going to start with this $5 per race. So I can see per involved in it. The per race is going to have to match with the slope. So they're saying this m is the $5. And we'll just keep our unit on it for now there. Okay, so, and the reason it's per, or reason our slope has something per in it, just as a side note, so remember our slope is a rise over run. So this is a rise. Division is another way to say per, so it rises however many units per however many run units. So that's why it connects with these word problems. Okay, so our per, that's going to tell us the slope. And then, well, we only have one other number involved, this $30. That must be the fixed cost. So our $30, that is going to be the B. So that's the fixed cost. The reason that it's called fixed is, well, like breaking down this scenario, this $30 is what anyone has to pay to just get into the park. And then it depends how much more they're going to pay depending on how many they race. So this is fixed for everyone. And then the per race thing, well, that depends on how many races somebody wants to do. Okay, so now all we're going to do is just put it into these. So we've got our letters ready to go. So we've got C of x is equal to m, which is 5, and then x plus the fixed cost of 30. There we go. Okay, so this is our cost function right there. Okay, and then they did say identify all variables used. So it would be C of x is the cost to enter and do X races, whereas X is the number of races we would want to do. Okay, so that's what those variables mean in this problem. And we can kind of always check. I mean, this is a pretty easy, say, real-life scenario you could do. Say you did want to go to this place and say you wanted to do 2 races. Well, that would be $30 to enter. 2 races would be 10. So it looks like you should be spending 40. And then, well, let's verify it with our actual cost function. So the number of races is 2, so that's our X. And then this is how much it should cost. So we could do C of 2 is 5 times 2 plus 30. And then, well, yeah, that's C of 2 is $40. Okay, so this here, this abbreviation is saying the cost for 2 races is $40. So that's that. Okay, so let's break down some other problems. Okay, so and again, once you get used to it, you can crank these out pretty fast. Just make sure that you do pay very close attention to what the variables mean. That's helpful for kind of future stuff in math. Okay, so in this example, it says assume that each situation can be expressed as a linear cost function. Find the cost function in each case. Okay, so they're saying our cost function, let's just go ahead and get that set up. So C of X equals mx plus b. And then now let's break down what these numbers mean. So they say fixed cost is 200. Okay, so the fixed cost is 200. That is our b. I'm just going to put it way over here. So that's the vocabulary for the y-intercept. And then they say it does, they say 10 items cost $800 to produce. Okay, so this needs further breaking down, so we can't just plug it in like we did for the above problem and be done. We need a little bit of extra work. Well, let's break down these numbers. So for instance, and we can go ahead, let's go ahead and do that in this step. So I don't know what m is yet, but I can plug in the plus 200. So you don't have to wait until you have everything to start working with part of the equation. So let's go ahead and just do that just to show it. And then now let's break down the rest of this in the purple. So they're saying 10 items cost $800 to produce. So the 10 items must be X. So X is the number of items. Because we already know the cost must be that dollar amount. So C of X, that is the cost in dollars. Okay, so what they're saying here is we have 10 items, and it costs $800 to produce. Okay, so we're going to let X equal 10, and we're going to plug it into this one. So let me just go right here. Let's use sub in X equals 10. So we have C of 10 equals, so again, we don't know what this m is. That's okay. But we can change the X into 10. And then we still have the plus 200. And then what we'll do is say, well, when we let X equal 10, we're also going to let the cost equal 800 in this same thing. So they're saying the cost of 10, so this part right here, they're saying just go ahead and change it into 800. And then from there, we still have m times 10 plus 200. And then so, looking at this equation, we have all numbers involved except for one letter. And that means it looks like we can solve for this m. Okay, so if we solve for m here, we can minus the 200 over. So I'm going to squeeze that minus 200 right in there. And then that way we would have 600 equals. Now this is where it's a little confusing with the function notation. At this point on the right, this is purely multiplication because this m is not a function. It is just a letter. So it's m times 10. So it might be better to write it as 10m to avoid any confusion. remember that you can multiply in different orders, like 2 times 5 is 5 times 2, so you can rearrange. And then that way we can see, well, if I divide each side by 10, it looks like I would get 60. Okay, so I'm a little out of room on that, but if we do divide by 10, the zeros would just cross out. Let me show it like that. So if we divide by 10, we would have 60 equals 1m, or 60 equals m. Okay, so let's go ahead and put 60 equals m, and I'm going to cloud that, because that's not our final answer. It just helps us get to our final answer. Okay, so we've got 60 equals m. Let's highlight. That's important to us. And the b that they gave us right away was also important to us. And then now let's go back to our original function. So all of these that are in the highlight are going to combine. So that way on our left side, we will just leave it as c of x. And then now let's sub in the 60 for m. So 60x, and then plus the 200 for b. And then that is our cost function. Okay, and we could verify it. They said it costs it costs $800 for 10 items. So if I do plug in 10 real quick into this, notice 60 times 10 is 600. 600 plus 200 is 800. So it is showing that the cost of 10 items is $800. So check. So we could always plug it back in to verify. Okay, so let's try one other. Let me kind of block that off a little bit. All right, so this time around they say the marginal cost is $40. Okay, and let's go ahead and write our cost function again just to have it ready. So it is a linear cost function. So let's go ahead and set up the form. And then we'll break it down. Well, the marginal cost, that's special vocabulary for the slope. So they're telling you right away that m is equal to 40. Okay, so that means I can change that to 40 right away as needed. And then they kind of break it down in a similar way to above. 300 items cost $8,500 to produce. Okay, so let's go ahead and change our cost function, change it into 40x, and then plus b. So we just converted the marginal cost. We just plugged it right in there. And then they do say 300 items cost $8,500 to produce. Okay, so like before, the number of items is x. So let's put that over here. X is the number of items. And then our cost is c of x. So c of x is, again, the cost. Okay, and what they're telling us in this underlined purple is we're going to let 300 items go into x. Let's write it like this time. So they're saying when you sub in 300, we should get $8,500. So I'm writing it in just one line instead of like what I did above. So this is saying the cost of 300 items is $8,500. So that's how it's broken down in mathematical notation. All right, well, using this in the purple, let's go ahead and change those x's in our main equation to the left to 300s. So we've got c of 300 is equal to 40 times 300, and then plus b. And then we'll change our cost. So they're saying this one right here again, this cost of $300 back to the right, so I'm kind of going left to right. So the cost to produce 300 items is $8,500. So they're saying, so change that left side to $8,500. And then from here, we do have 40 times 300 plus b. Okay, so now we've got an equation where we only have one letter involved, and we want to solve for that letter. So here, let's go ahead and do our multiplication. So 40 times 300, well, 4 times 3 is 12. And then we have 1, 2, 3 zeros. And then we've got plus the b. And then after that, we can subtract the 12,000 over. So we've got minus 12,000, like that. And then that way, so the 8,500 minus 1,200. So I'm going to go ahead and use my calculator real quick here. And we get negative 3,500. So we've got okay, so our B is solved for, so I'm going to cloud it. And then from there, let me highlight it as well. So we have our B, we have our slope from the start, and then we had our original equation from the start, and we're just going to combine all of those into one to get the final cost function that they want. So C of x equals, so change the m to 40, and then plus b, but it is minus 3,500 in this case. So there we go. So that is our cost. Okay, so there we are. Now, this problem, there is something weird going on. So we did everything right, but because this is an abstract problem, okay, so it wasn't a real word problem. It was just kind of just to set it up. When this happens, so a real-life application should never have a negative fixed cost. Like that. Okay, so it should never have a negative fixed cost. So currently our fixed cost is negative $3,500 because what that is telling us, so it's got something really weird going on. So for instance, if we plug 0 in, it would tell us the cost to produce 0 items is negative $3,500. So negative in that case would be like you're earning money, because it's so a negative cost means you're getting a return on it instead of actually paying for a cost. So this negative really doesn't make sense because it should never cost, or you should never get money for a cost function. So cost function is costing you. You shouldn't be getting rewarded for it. Okay, so anyway, so this is an abstract one. I'm just going to leave it as is. But if it's a real-life application like the ones that you might see in the book, or any real-life application that's not even in the math book, the fixed cost should be a positive. So that's as a heads up in case you're working on something and you do get a minus. It's probably off. Now this problem, everything is correct because it was weird numbers that were just made up. So that's okay for this problem. But again, any real-life situation, this would be impossible. Or if this is a real life situation, you would need to jump on it because it's like doing nothing and making money, which would be awesome. Okay, anyway, that's it. So if you do have questions, please let me know. Otherwise, thanks for watching, and I'll see you again soon.